So thanks for joining this session. This is Understanding Multicluster Kubernetes Connectivity Options. I promise I'll find a longer name for the next session, so I can take up the whole page. My name is Shannon McFarland. I'm a distinguished engineer at Cisco. I work in the Emerging Technologies and Incubation Group. We're basically Cisco's internal startup and innovation engine. And the best way, even though it's becoming unpopular to be on Twitter, at IPv6 is the best way to get a hold of me, and I'll be around for the rest of the week. So what we're going to kind of talk about are some of the use cases aligned to justifiable times when we need to link up Kubernetes clusters. And we're not going to be talking about all the infrastructure dependencies underneath the clusters. So if you're doing hybrid cloud designs where you're doing transit gateways or VPNs or colo facilities and you're linking all of these clusters and regions together, that's a totally separate topic. What we're going to talk about in here is when you do need to expose services or discover services across the multitude of Kubernetes clusters, what do you need to do inside of those clusters outside of just exposing a standard service over a standard ingress or load balancer? So we're going to talk about a few projects that are available to us to do things like service load balancing, global distribution of these services, whether you're doing like a GSLB type of use case, or maybe you're just doing something as simple as exposing data in something like a Redis environment on one side, and you're just simply creating a replica of that on a service-to-service dependency model on the other side. So there are a lot of different projects and products out on the market that kind of help do this. What we're going to talk about in here today are a few of those. So what I absolutely beg of you to do is to go into your session scheduler and download the PDF for this session, which has 68 slides. We're only going to go through about 13 in here, but every command to install everything that we're going to talk about in here, the packet traces for VXLAN, all of that stuff are in your slides. So for our 30 minutes together, we're just going to really kind of touch on the highlights. The ones we're going to talk about is a sprinkling of solutions that I personally have done design and deployment stuff with. So there's some that are like Scupper, NSM, or Network Service Mesh, or other projects that are in this space that we're not going to talk about today. But the ones we're going to talk about here briefly is a CNI-based approach, which is Cilium Cluster Mesh. This is the Cilium IO that you know of, the eBPF-based project. This is an advanced extension of Cilium called Cluster Mesh. We'll also get into some uses of application service meshes as well, so layer 4 through 7 type of primitives that also do multi-cluster connectivity in addition to all of the normal Kubernetes service mesh-oriented things that we like to talk about. So we're going to sprinkle through a couple of the use cases. The first one is just a generic global load balancing solution. We're going to talk about Cilium Cluster Mesh in that use case. And then over on the service mesh side, we're going to actually talk about pinpointing very specific services in each of your clusters and linking those services and their back-end pods together using these projects. So if you don't know anything about Cilium.io, you've not been paying attention. So this is a pretty hyped project, eBPF-based networking, observability, and security solution. So there's a lot of discussion around Cilium. It is a CNCF project. What we're going to talk about in here today very briefly is Cluster Mesh, which is a use case or an extension of Cilium. It is very, very good at doing global load balancing of services, and we'll topologically take a look at that here in a moment. One thing that you will look at in the PDF, though, is you can hack together a service-to-service model. That's not what it's for, but you can do a service-to-service environment there, but that's really not a strong suit. But I did show you configs on how you implement that environment. So this topology is the same topology we're going to use through every one of our use cases. The reason why I do that is so that you can very easily rinse and repeat every single config for every single project we talk about in here in your own environment and get a very nice pros and cons comparison between what one does versus another. So what we've got in this environment is we've got two Kubernetes clusters. I don't care how they got there. And we're using the Google Microservices sample app, or boutique service app that you may also know it as. And we have a full implementation of that project on both sides. I've cleaned out the ingress and front end stuff over here on the right-hand side just to keep the picture clean. because we're really not going to be looking at how we share those particular services. We're going to be focused on the Redis cart service. But what you do in Cilium, as you'll see in the PDF, is you would utilize Helm, or you would utilize an operator, or you would use the Cilium binary, and you would install Cilium from a CNI point of view. You would enable the mesh, and then you would establish a data plane connectivity over VXLAN or Geneve, or if you're in a native routing mode, then you wouldn't be using an in-cap style. So once you have that control and data plane implementation there, then it's time to actually go and expose your service that you're picking to do your load balancing against. So all you need to do, and this may be difficult, I know when I was in the back of the room, it was kind of hard to see the smaller font, so if you squint hard enough, maybe you can see this, this annotation we're adding here. But all you have to do, once Cilium Cluster Mesh is deployed on the clusters, is go to the service that you want to globally load balance and add one annotation. So this annotation is global-service true, and the second that gets lit up inside of Cilium etcd, which is what's synchronizing the state between the clusters, all get together and figure out that they can now create a mapping. And this mapping is called a service list in the Cilium nomenclature. And so all it is the IP address of the service that you are sharing, and then it goes and looks across all of the clusters at the Cilium and etcd level and finds any backends or pods that back a service by the same name. So that way, for example, if cart service is talking to Redis cart, it now can hit this front end by name, and it can basically load balance across both clusters over the VXLAN or Geneve encapsulation up here and talk to the various backends. That's it. One annotation, and you've now shared a service across 100 clusters or 2 clusters, whatever the case might be. If you want to have a bidirectional load balancing so that things in this cluster also load balance, then you would just simply do a service definition by the same annotation on this side, and now anything that comes here gets load balanced this way, anything that comes here gets load balanced this way, all through a single annotation. So pretty simple use case, but again, probably not the best use case for it if you are picking out one very specific service deep in your architecture and trying to expose that from a point-to-point point of view. Now let's get into that example. Let's get into that service-to-service or pod-to-pod example. So Linkerd, how many people have heard of Linkerd? Okay, a few people. So Linkerd was the original modern-day application service mesh. It was even there before Istio. It is a CNCF project and pretty popular project. And from a Linkerd point of view, and again in your slides, there's a whole architectural walkthrough of what Linkerd is from a control and data plane point of view, how do you install it, all that good stuff. But from an implementation point of view, again, you would use Linkerd or Helm to get Linkerd installed in your clusters along with your workloads. And once you basically expose Linkerd from a mesh point of view, you then install the Linkerd multi-cluster configuration. And once you do that, it is basically going to create load balancer objects or node port objects or cluster IP objects, depending on what you choose from your multi-cluster data plane routine. And it's ready to go. So what you do once the control and data plane is implemented in all of your clusters, and you've implemented the multi-cluster linkage between the two, what you're going to do is identify the 2 clusters that you want to communicate with. It's going to go install a single reference, that is the gateway itself. And then very similar to what you would do inside of Cilium Mesh, which was an annotation-based, Linkerd has you just simply label the service. So you would run a label service of your namespace and identify the service that you're trying to label, and you label it as exported true. What it then does is it creates what is known as a service mirror. The service mirror is named the same in all cases. It's the name of the service and then the source cluster the service is coming from. So in this particular case, it's Redis-cart. That's what we shared. The name of the cluster is Linkerd MC1, and it basically appends that to the back end of it, and it creates this service mirror that way. Now here's where the magic kicks in. Once it does that, Linkerd takes care of letting this cluster on the right-hand side know how to get back to the actual service. So it does it, if we're networking nerds in this room, kind of like a Nextop idea, right? It utilizes this endpoint configuration where it says, if you want to get to me, Redis cart Linkerd EMC1, you're going to come to the load balancer object that I've identified, in this case is an AWS ELB, and you just simply understand how to get to that endpoint. Now, when we go in and we do a replica of, we reference that service mirror, and now this pod knows how to reach this pod by simply leveraging that service mirror. Linkerd is literally taking care of all of the DNS, all of the service discovery, all of the MTLS trust bundles and boundaries between the gateways, and just simply routes the traffic from one cluster to the other. So this is a very, very smooth and simple way of getting multiple clusters to do very, very 1Z, 2Z type service exposures. Now Istio, another application service mesh, does things similar but a little more complicated. So Istio, another wildly popular service mesh that's out there, does similar things to what Linkerd does, and it does it in such a way that it provides a multitude of multi-cluster connectivity options. So you can do things like multi-primary, where you have two fully deployed Istio control planes on each of your clusters, or you can have a primary control plane and somewhat of a stub of a control plane in a remote cluster, which may be actually really good in an edge circumstance. It also supports a multitude of networking options, single network, multi-network, and so forth. So a lot of those configs are all in the deck. So again, taking a look at our same topology, the way Istio is doing this is that Istio has normal control and data plane objects, so things like pilot and so forth, which is now Istio-D. It creates an Istio ingress for its normal control plane linkage, and then you download out of the GitHub repo this script called the East-West Gateway script, and that's what actually builds a second load balancer object in each of your clusters, and this lets the service discovery between these particular clusters be advertised, and then obviously all the MTLS trust is all handled by that particular gateway. So there are a lot of configuration steps to this. When you look in your PDF, if you count them all, there's roughly 19 steps to simply get the gateways functioning. This does not include actually deploying your service mirrors and so forth. So it works beautifully. There's a ton of flexibility. You can do isolated trust boundaries and PCI type of environments where you can't ever allow certain things to leak from one cluster to another. So there's a ton of capabilities in here, but it's also a lot of configuration to get done. So very much like we looked at in the use case with Linkerd, we create a service mirror in this configuration. The downside between Istio and Linkerd comparison here is that Linkerd takes care of one, right out of the box, all of the DNS discovery setup between all of the clusters. So you don't have to figure out if a service gets created in another cluster, how do I resolve to that name, right? So you actually have to set that up inside of Istio as a special parameter in your Istio operator or in one of your service configurations in there. Linkerd kind of takes care of that on your behalf. The second thing that's different between the way Linkerd and Istio work in this configuration is that Linkerd, the second you create that label and say this service is the one I want to be exposed, it creates the service mirror for you in all other clusters. In the case of Istio, we have to create it. So it's pretty simple to do. If we want to have a mirror of Redis-cart here, all we have to do is copy that exact same service definition, change its name, and then apply it to the cluster. That's it. So in this particular case, Redis-cart-CLS1, you name it whatever you want to name it. But if it's got the exact same service definition, what happens then is that we've created a local service mirror that Istio is going to automatically replicate to all other clusters. And it does that via the configuration of the East-West Gateway. So in the east-west gateway, there's this host section that you really, really, really need to pay attention to. Because by default, if you were to do a star dot or a star dot local, every service, the ones you want to share or not, every single service you have in that cluster is going to be populated in all the Envoy sidecar proxies in all other clusters. So if you've got thousands of services and you only wanted to expose one, guess what's in Envoy? All the thousands of services, not the one. So this is one that you really want to pay attention to for not only scale, but from a security point of view. So in the slides, I've got an example. You basically just identify the service name, redis-cart dot namespace service, cluster.local, whatever it is that you want to do. You enter that in the host field versus a wildcard. So in this particular case, we've got our star.local in here. So the second redis-cart CLS1 hits the cluster and Istio knows about it, it immediately goes and tells every sidecar proxy in every one of the pods and all of the other clusters about it. And it tells it 2 bits of information, very similar to what Linkerd did. It tells it how to get to the cluster. That's that endpoint value. So it says, hey, if you need to get to this cluster where this service resides, you're going to come to this endpoint, which again, in this case, is an AWS load balancer. The second bit of information it tells it is the listener information. The listener information is simply the pod service kind of communication layer that we need to tell our pod about the internal or the cluster IP address of the service itself. So this pod will now know, okay, when I need to go to this particular name, redis-cart CLS1, Istio is going to intercept that. It's going to pass me to this AWS LB. This gateway is going to look at its TLS mode. In this case, it's auto pass-through, which means it will not terminate on the gateway. It's actually going to pass it right on down to the cart. Once we're down to the cart, it will then pass it down to whatever listening pod is sitting there, okay? So that's kind of the day in the life of a packet in this scenario. Lots more configs and lots more things to kind of walk through there inside of the presentation. So just like with the past version that we had with Linkerd, we drop into our Redis cart, we do a replica of the new name, and then Linkerd or Istio is taking care of the rest of that config. Clear as mud, yes? So we talked about the complexity of what Istio is doing there, right? I mean, and it is super capable, and it's magnificent. There's a lot of complexity to Linkerd, and even under the hood, there's a lot of complexity to troubleshooting things like Cilium Cluster Mesh. All of them kind of have their weight from an operational point of view. So something that my team has released is a service mesh management solution built on Istio, but it removes all the toil of configuring Istio in things like a multi-cluster configuration. So we'll spend time with that for just a second. So Cisco Callisti, go to callisti.app now. You get 2 nodes up to, 10 nodes for 2 clusters for free forever. And if you want to expand your environment, you can go to into a higher licensing agreement. But you can deploy everything that I've talked about in this session today for free in production Callisti environments. And what it's really there to do is to operationalize the day-to-day management of running a large service mesh. So it's there to provide very, very easy multi-cloud, multi-cluster connectivity options. So as we'll see, it basically subtracts those 19 steps to 3. And it then provides you a total graphical way of managing these clusters, doing all of your policy around things like service level objectives between services in multiple clusters. And then obviously it's there to simplify the service mesh management itself. So if you've ever run a service mesh and you're trying to do minor or major version updates of your control plane, these are all fun times, right? I used to have a full head of hair prior to getting involved in the management of service meshes. And so this solution is really focused on trying to reduce that toil. So as we mentioned before, there's a bunch of steps involved in deploying Istio. In the case of Callisti, once you download the binary, you just simply install it against your first Kubernetes cluster that you're eventually going to link into this cluster. And all subsequent clusters from that point forward out, you just simply do a cluster attach. All of the other 19 commands I told you about, you don't have to do anymore. You don't have to run the Istio CTL. You don't have to run the operator. You don't have to tweak an east-west gateway, MTLS pass-through. All of the leaking of services you can handle from inside the actual management structure of that, and away you go. And so it's just rinse and repeat across 1 or 1,000 clusters. It just makes it much, much easier. And so you can actually see those things start to stack up. And this is where the multi-cloud part of this comes in too, right? Is because we sniff out what your distribution is. So if there are unique things that you're going to do in a multi-cluster config between GKE, AKS, an on-prem environment, or you're running something in Rancher, we're sniffing those changes out, understanding what your environment looks like. And then when we do these gateway configs based upon a load balancer object or a node port configuration, something like that, it's detecting the environment that you're in and not really making you have to go out and tweak a bunch of YAML files. So once you get that done, you end up with basically a nice looking topology that is multi-cloud and multi-cluster aware. So I know it's really, really hard to see in this room given this screen, but basically you can go through here and find out all of the protocols, all the layer 4 through 7 protocols, gRPC, HTTP, etc., between all of your clusters, the health of all of your services and their subsequent pods. There's also some really cool features in there, like if you've dealt with Linkerd, there is kind of this Wireshark for service mesh thing that they've got called the tap feature. We built the tap feature into this solution. So you can have a layer 4 through 7 sniffer, if you will, inside the cluster and between the clusters. So if you end up having a high latency event between the clusters, maybe you've got, maybe you're traversing a transit gateway config, or you're actually just going over the top over the internet and you're hitting a delay. You don't have to go and chase the delay in the meshes. You can actually identify, is the delay in transit between the actual clusters themselves. So there's some really cool functionality inside of that environment. So this was a barn burner of a run through on things that you can go home and do some homework on staining this stuff up yourself. So I would recommend that based upon your requirements, evaluate these things from the lens of, do I just want to create multi-cluster connectivity and that's all I want out of the tool set? Or do I actually want more things like observability, security policy, a better developer experience, those types of things, in addition to getting multi-cluster connectivity, right? That's kind of the lens that I would look at this with. So for example, if you're already a Cilium house, you're already kind of going down the path of really just standard network primitives inside your clusters, and all you want to do is global load balancing. It's kind of hard to beat Cilium's approach to this, because it's just that annotation just makes it a pretty brainless operation, right, for you to be able to synchronize these things across there. Submariner or Submariner, however you like to say it, is another great approach. There's a lot of config, and it's a much more complex solution, but once you get it running, it's a really, really nice solution. It's a standard kind of router or gateway-based approach, where you're implementing a standard gateway. You're just doing it in a cloud-native way, and it's really cool. You can do IPsec, you can do WireGuard, you can do encryption over, with VXLAN. There's a lot of connectivity options that Submariner has, if that's the approach. But again, like I say, if all you're wanting to do is pure connectivity, those two are the ones that you could probably pinpoint. But if you're trying to get connectivity and a bunch of other additional benefits, service meshes are probably your better way to go. They are easy to actually operate between the service-to-service connectivity model, but then you're getting all of your deep observability, all of your tracing, integrations with Grafana, Jaeger, Prometheus, all of those things are cornerstone elements of what you get in a standard service mesh in addition to the connectivity model. One that I didn't touch on in here is an up-and-coming kind of project in this particular space is NSM or Network Service Mesh. So this is one that Cisco is quite involved in. This is a CNCF sandbox project. And NSM has got a very unique approach to this. NSM's approach is really focused on specialized use cases where you want to link pods together in multiple clusters, but you don't want to go about it through a CNI path. A good use case of this is if you've got very, very high rate data replication use cases where I'm either going to be passing through someone else's defined network policy out their CNI interface through a standard, ENI or whatever it is that I've got. And I don't really have many bells and whistles for me to go and tweak to say, this one workload is going to go on these particular nodes with this one high performance interface attached to them, right? You can't really get that kind of configuration without a bunch of, multis tweaking and things like that. So NSM allows you to identify pods and shim a brand new interface into the pod at basically at bootstrap time. So now you've got your regular CNI path that you're always using. It obeys network policy, all of the normal constructs that you have through standard CNI rule sets, but it plumbs a brand new interface in that only allows point-to-point connectivity to any other pod that is in its what's called a network service domain. And so this is a really interesting use case where you don't want this massive amount of toil and burden of configuring service meshes and all of this other stuff. You just want this pod to talk to this pod over a very specific interface over whatever protocol you want, IPsec, whatever it is, and you want to be able to then schedule that interface on specific nodes that may be of a higher instance caliber, so you have higher throughput. Maybe you're in on-prem, and this is actually tied to hardware-based network interface cards. So it's a pretty neat approach to be able to go and run through some of this stuff. Again, go to callisti.app today. You can download the binary, shove your email address in there, and it'll send you a license, and you'll be able to get 10 nodes with 2 clusters and be able to go and do some of this multi-cluster testing. Final part here is these specialized per service kind of cluster connectivity models. Again, I would go through every one of the examples that I have, step them up, or set them up in a kind cluster, an EKS cluster, whatever it is you like, build it in a multi-cluster way, kind of look under the covers, take a look at the PDF and figure out there would be more to this than just what Shannon's saying, right? There's ramifications for, am I doing a multi-region, multi-VPC config? What do the security groups look like, right? If I'm going to open up port 443 or I'm opening up ports for VXLAN all over the place, what does that look like on the infrastructure that supports these use cases? So these are things that I would not just say, that one looked good on his slides and go and start spinning this thing up in your production, right? I would really go and take a look at every one of these by hand and do these comparisons yourself. So that's it. Any questions? There can't be, right? That was so slow and well-paced. Go ahead.
So you mentioned in the Cilium that it just works, but it may not be what you want. Could you elaborate a bit more on that?
Yeah, it works wonderfully for global load balancing. But if you're in that use case where for example, I had Redis over here and I just wanted to create a replica Redis cart of just Redis over here directly, the constructs of how you expose services via those annotations make it somewhat more cumbersome to achieve that. You can do it. I call it selective load balancing, where you basically, in that annotation, you create a second line, which in the PDF, there's an example of that exact scenario, where it says, this service is global in that it is reachable, but I do not want to advertise it to the rest of the world, right? And so you can actually create a very kind of pseudo service-to-service model, if you will. But that's what I mean by that. It's really good at the global load balancing, but if you're really there to not do global load balancing, you just want one service to be shared to another service in another cluster, that's not its strong suit.
Another question to follow. What do you think about this whole sidecar versus sidecarless debate that's been going on between Linkerd and Cilium folks?
Yeah, well, I mean, it's actually it's a broader approach. I mean, if you actually go to the Bytecode Alliance folks and start talking to WASM folks over there, they'll be in the sidecarless world too, right? I mean, even though you got WASM filter capabilities in Envoy, and Envoy's a sidecar, there's a lot of movement and a lot of justification for doing all of the beautiful things that you get in service mesh, but without a sidecar. So, so I know William from Buoyant very well in his anti-sidecar, mentality. I think there's a use case for both of those models, right? Where you want to get the benefit of deep observability, zero trust kind of configuration, service discovery, all of those things that a service mesh is really good at, but you want to lower the latency of a sidecar injection, or you don't want to have to deal with the life cycle management of the sidecar. So I think both of them are legitimate, and I just think it's a use case basis thing. Yep. Go ahead.
Thank you for the great presentation, first of all. My question is about multi-cloud connectivity. Basically, how do these multi-cluster connectivity options perform when the clusters are distributed among multiple data centers or even multiple clouds like prevalent, AWS, and Azure?
So are you saying, is it capable to do those same things? Yeah, absolutely. So all of the types that we have listed here, you can expose services via a multitude of ways. So you can do load balancer type. So if you're in a hyperscaler environment, it's going to expose the load balancer type of that hyperscaler, ELB, et cetera, right? If you are in a node port or a cluster IP model and you have, intra VPC connectivity, or you're in the same region or whatever, and you can monkey around with your CIDR approach, you can get that done as well. So every one of these approaches would allow you to do this in a multi-cloud, multi-region, multi-VPC, inside a region, all that other stuff. Every one of them have primitives to allow for that. Yeah. Go ahead.
Curious on your thoughts about the ambient mesh.
Yeah.
Splits things up with optional proxies.
Yeah, so the comment is about ambient mesh. So ambient mesh, for those of you that don't know, this was a recent integration option for Istio. The folks at Solo.io and Google kind of got together, and now it's a project everybody can participate in. But ambient basically provides a lower toil way of establishing kind of a sidecarless like approach. What it's doing is it's taking the sidecars away from the pods for multi-cluster connectivity, and it drops them down to the nodes and turns them into a gateway. So it's kind of like the Submariner approach, where you're actually deploying your multi-cluster connectivity down on the nodes themselves and establishing a mesh of gateways. So it's very similar to that kind of concept. And of course, you can still use the sidecars, that are associated in the mesh already. So it's a great approach. We'll just see, how that matures. So I think, to your point, we'll have a sidecarless world, we'll have standard sidecars, and we'll have a gateway model, which is kind of the ambient mesh approach. Yes, sir.
So this is about legacy. Is any of these solutions capable of dealing with overlapping subnets?
Absolutely. Yeah, so the question is, are any of these capable of dealing with overlapping subnets? Yeah, so depending on the network model that you align to, for example, Cilium's got native routing mode, and then it's got, basically an overlay mode. Depending on what solution that you pick in there would drive you towards whether you can support hierarchical networks or not. For example, Linkerd, they only support a hierarchical model. So they only look at a situation where the routing constructs can be whatever they are. We don't care, they don't really look at a flat network requirement where you can have, basically a non-overlapping config only. So it depends on the networking model inside of them, but pretty much all of them support a situation where we don't trust that you're not running NAT, so we're going to proxy that address space for you. Yeah, and again, we couldn't cover it in here, but if you actually go to each one of those links that I provided in there, you'll go to the multi-cluster site, and pretty much all of them do a bang-up job of explaining how you would do things in a colliding space or in a disconnected space where you're in a private network kind of thing. So most of them all have models for that. Cool, we're over time, folks. If you have any additional questions, I'll be out front. Thanks a lot. Have a great week.